Before we get started, I just want to plug our regional convention that we'll be holding in May in the Michiana division. So here's the flyer. There's more information on the Midwest region website. But May 2nd through 4th, make plans to come to the Century Center for Around the Bend, which is the 2024 Midwest Region Convention. We are several people on this call are on the committee that's planning it, and we're excited about it. It's going to be a great time. And many people on this call are going to be clinicians at the event. So thank you for your help. And so more information, you can go to 2024aroundthebend.com, or you can go directly to the Midwest Region website and check it out. So that's our a message from our sponsor, so to speak.
Yeah.
So anyway, today we're really glad to have George Toman with us. He is going to give a presentation on working with metal parts and etching, that sort of thing. He gave his presentation a couple times before, once at the Naperville RPM convention, and once at another one. I can't remember the name, but George, let us know what that is. This we're recording today, so this will be up on our YouTube channel later this week, and of course, all you folks are going to get to see it here locally, so you won't need the recording. But George, take it away.
I'm George Toman. I've been a lifelong modeler in trains and occasionally cars and boats, as probably everybody. This presentation I gave twice at the Chicagoland RPM meet in October, and once on Hindsight in December, which is a Zoom meeting we have. And then we had a request that to do this again, and I got involved with the Michiana division here, and they suggested to go ahead and present. So here we are, January 20th. This is for personal use only, and we're going to talk a little bit about working with thin brass and photo etch parts. So let's get started. On the left, you see a picture of some thin brass wire, flat stock strips, various different pieces there. And I'm going to make a few suggestions on how to make these parts. And on the right, you see photo etch parts. The large pieces here in the upper left are custom etchings I did for ladder styles for a Milwaukee Road ribside boxcar, along with modeling friend Tony Sissons, who did the CAD drawing, and we sent it off to the UK to have these etchings made. The lower right are some Yarmouth ladder styles, and you see a somewhat completed ladder there in the lower right, and we're going to talk about some of these things. So the following presentation contains some of the tools and methods that I use in my modeling efforts. These are work practices that work for me. You may find that you have other tools and methods that work best for you. And I had somebody comment that the tools I use and show aren't necessarily the best. All I'm going to say about that is some of the ones you see here I've been using for 6-7 years now. So you could go ahead and make your own judgment on the tools. And because I injured my right hand in a landscaping accident, we'll leave it at that, with the finger, I don't have full dexterity, so these are tools that I find work for me. The photos you see in this presentation have been taken over the past 5 or 6 years and show samples of the tools to build actual models. And I'd like to thank many friends that have, through the years, have helped me: Bill Welch, Ted Collada, Ryan Mundell, Tony Sissons, Lester Brewer, and others who have inspired my work. So the topics we're going to talk about today are why I do this, sources for brass, tools I use for working with brass, cutting thin brass, making parts, making photo etch ladders, lateral running boards, attaching parts, and improving the strength of some of the parts. Why I do this? If you look at the upper portion of the screen, you see what's called a general arrangement drawing. That's one for, I believe, a Rock Island automobile car. And on the lower right, you see the results of me interpreting and making and constructing and scratch building a underframe using that drawing. And in this photo, you'll see the car that it's actually attached underneath. This car was from a 2015, what they called shake and take, made from an Athearn MDC, ready
Hey,
to roll,
Mr. Pierce,
boxcar.
how are you?
It,
Good.
it was upgraded with custom cut and formed brass and photo etch parts. You can see the finished one in the upper left. The upper right, you see the roof with some of the lateral running board brackets, the ladder, and you could see the B end of the car with some of the custom bent parts. The shake and take is run and offered every year at Cocoa Beach Prototype Rails, I believe it's called. It's in January. I've never been to it, but I was able to get some of the parts for this car to go ahead and build it. So sources for thin brass that I use, and that ranges from 1,000ths to 10,000ths, with 3,000ths and 5,000ths being my favorite sizes to work with for all the parts that you see here. K&S Brass is a good source. They sell a small package, and you can see here a rectangular piece here in the upper left of the photo. They offer a variety of sizes from 1,000ths to, I think, 6,000ths shim stock in there. There was a larger sheet of K&S brass. I believe that was 10,000ths. And also you see here detail associate brass wire and flat stock. Simpson makes some small brass flat stock and wire that they still offer. Simpson has been around for many, many years. Precision Scale offers some wire you could order direct from them. Tichy phosphorus bronze wire, very much like brass. And you could get sheet flat stock, often noted as shim stock on Amazon, eBay, and other places. Another place I've sourced angled channel in that and wire is Albion Alloys
trying.
Precision Metals.
How'd
It's
you do
a-
with the show?
It's a company out of the UK that does sell various small size wire tubing and shapes. However, it seems like it's disappearing from the US markets here of late. Here's a photo of some photo etch parts and resources. On the left side of the screen, there's a company called National Scale Car. They offer some brass photo etch parts, but they offer more their photo etch parts in what they call mini kits. And you could see some parts here from National Scale Cars from one of those kits. Yarmouth Model Works is a big supplier of photo etch parts in the center. And Plano, I think most everybody recognizes they have quite a few parts, running boards, etc. So let's talk a little bit about the tools that I use for measuring and layout, cutting, bending, forming, attaching, and drilling. My measuring tools on the left, and this is actually a small sample. I love tools and collect a lot of tools. I show my Brown and Sharp digital calipers. I think everybody's familiar with the standard steel scale rolls. And then I have a roller here that's in tenths of an inch. And I really do a lot of work in the tenths of an inch in that between the calipers and the scale roll. So that's my favorite method of or unit of working with is in tenths. On the right, you see a magic marker, and That I use as instead of layout dye. So I color my brass. I often clean the sheet of brass or what I'm trying to mark up with alcohol or a scratch brush to clean the brass, and then use this as a layout dye. You see a little scribe here in the center, and then three different squares: X-Acto, an old Craftsman, a small one, and the larger one here on the right is a Micromark thin beam square, which is nice because it's a very thin edge and doesn't lift up on an angle as much as the like the Craftsman here. For bending on the left, you see some photo etch bending tools and some pliers. The silver ones, and you see three different ones here, a long one here on the upper left, the upper right, and a shorter one. These are from a company called UMM-USA. They're out of a source here in Illinois that deals a lot with military tools and that. And these I've upgraded with some what I call star knobs for tightening. We'll talk a little bit more about these in a minute. And by the way, all these tools and that I talk about were in a handout that I gave, and there was a link posted earlier this week, so you could see and access where I got these. The center photo etch bending tool, that's red and black here, is more the typical looking tool, although it's a small square one. If you look at it, the front edge here is straight, and you see different fingers on the right, the left, and there's actually at the rear. When I loosen the knob up, I could actually rotate and access these different bending points. I use these very seldom in that. My go-to tools are the on the left here, Tamiya tweezers, which are photo etched tweezers. On the right, you see some pliers here with black. These are Tamiya style of photo etch bending pliers. And then Xuron makes a nice set of smooth nose pliers, number 450 here, and with the blue handles. Cutting and scoring, I have a heavy utility knife here, a Stanley one, I believe. And this comes in heavy and good handy when you're cutting thicker brass, like 10,000ths brass. Even though 10,000ths sounds thin, when you're going to cut it and score it and bend it, you need a good good heavy tool. Standard X-Acto number 11 blade. You may use a scalpel or whatever cutting device you like. In the center here are some Xuron shears at the center top, number 9180, and that's a shear, and the micro shear has a shorter point here, that the bottom one with the light blue handle. In the upper right is the some cloth shears, which are nice heavy shears for cutting brass. And if you have any questions, just feel free to stop and ask me. Most photo etch bending fixtures and pliers have a angle to bend past 90 degrees. So if we take a look at these UMM-USA benders, and that the far left one, the shorter one with one handle, has an angle here, you could see by the arrow, and there's one on both sides. The longer one has an angle on the left, but the right has a straight. And this was an older, these became available, I want to say 6-7 years ago. So I've had these for 5-6 years. On the photo on the right, you see the Tamiya photo etch bending pliers, and again you see the angle. And again on the photo etch bending tool. So why is this angle? Let's take a look. And using the photo etch bending tool, the longer one that had the square or right angle on the left, and the plus 90-degree angle on the right. We're going to take a sample piece of brass. I believe it was 5 thousandths, and I put it in the tool, tightened it down, and just made a quick bend. And then I pulled it out, and on the right, you could see the results. You could see by the red arrow where the 90-degree bend was, how this is a poorly formed, and it is not a true 90 at all. You can see it goes up on an angle, but what's important here is by the little red arrow angle, it's not a tight 90. It's a very loose, sloppy, rounded 90-degree turn. And you could look here on the far right by the yellow angle, yellow arrow, and you could see that it's a very tight 90. Now, all I did was take and bend these quickly, and that I didn't try to tighten them up for that. But you can see how it stands up straight, and it looks like a very nice, tight 90-degree. Here's some of the devices, pin vices and drill bits that I use. Some of them, because I'm a tool junkie, I have way more than I should. I found some German bits that I just absolutely love. They're extremely sharp. But since the pandemic, they've become very pricey. They're almost up to $30 for one bit now. And I was buying them on eBay and other places for sometimes $2, $3 a bit. So I use these cautiously now. These are Goering drill bits. There's others companies that make these micro bits, extremely sharp, extremely brittle, but they do work well. I put sizes on mine because when I purchased these, they were in millimeters. A friend of mine told me once that if you're drilling a hole, and say you want a drill hole for a 8 thousandths wire, you don't buy a number 8 thousandths bit, you buy a 9 thousandths bit. So that's why you see I have 9 thousandths here. On the right, you see some bits from Rogers drill bits, also marketed under the X-Acto. I've had this set ever since I was a teenager. It's the same one with many bits, especially the small ones, replaced many, many times. The left-hand side, lower left, you see some brass-colored drill bit pin vices, and these are no-name, which come in very handy. They have very small collets. The center is hollow, so the bits could be pushed back into it. They were probably $4, $5, $6 a piece. The black handle ones are Stirrup. The smaller ones are number 166A. They have black plastic handles. They have anti-roll. They do sell these without the handles. They roll like crazy. I like these. They fit my hand better. Very good holding capability. A little bit more pricier. I do use a couple of cordless drills, and on the larger one is in the right-hand photo is a Dremel micro drill with a micro chuck 4486 chuck on it. On the left, it's a variable speed lithium ion, probably in the $50, $60 range. I've had mine for quite a few years. I ran across a smaller version made by a company called Newmaster, and there's a few other ones out there. You could go to Amazon or eBay. You could see the size of it. It's a lithium ion, rechargeable with a USB cord, multiple speed. I believe this is a 3-speed or a 4-speed. I think it's 3. Very small, very easy to hold. I have a number 80 drill bit chucked in there. These things are between $19 and $20 on Amazon, and there's a link in my handout. Great little tool.
I purchased one when I saw your clinic before, and it's a nice lightweight, not a lot of torque, but boy, is it easy to hold and use.
That's why I love it.
Yeah.
You don't need that much torque, because I think the more torque you have, the more you're likely to break some of those bits.
Yes. Yeah.
So cutting thin brass to size. when I first started and got back into the hobby after I retired, I started using these Xuron micro shear, and they make nice cuts, and you could see it's nice. It's every time you stop though, you leave a little dent in the brass. You could see here on the front on the left picture, and you can see here I did a better job here cutting it out. But every time you stop, you leave a little mark, and it curls. So I
Mhm.
thought, well, I got this idea from working on a diesel. I think it was a SD. It was actually a Milwaukee Road SDL 39 that I was scratch building, and I got some brass running board and that from Canon and Company, Photo-etched brass. Well, how do you cut it? And you don't want it to curl. So I tried a scribing method like you do styrene. I
Mhm.
was scribed it, scored it, and bent it, and it broke off very good. So ever since that time, I've been cutting my own little strips here of brass using with the assist of the photo etch bending tools, and we'll talk about that here. But one thing that's hard to do is to cut consistent pieces of brass to certain widths, and that somebody's at my door, but we'll ignore that. Cutting small strips from thin brass and styrene from shim brass. You could see here on the left are some samples of 0.003 by 30 thousandths and 0.005 by 30,000 pieces cut. And on the right is a angle that's made from 5 thousandths brass. And we'll talk about that in here in a second. In order to make small, consistent custom widths of brass and styrene, I use some homemade guides. Sizes of styrenes are suggestion only, and I usually use scrap brass for the heavier pieces. In taking a look at this white styrene made custom cut guide, the larger piece here at the back, top back, is made from 0.060 by 0.1 styrene, and I call that the beam. And you see I have 0.053 on there. I wanted to cut something to 53 thousandths wide for a project, and I needed multiple strips, and I wanted them to be as close as possible. So I came up with this idea using the beam, the heavier beam, making shim styrene to 53 thousandths thick. Well, 53 thousandths is an odd number. Typically, you don't find that. So what I did is to make it up from 0.040 by 0.060, and then took a piece of styrene that was 13 thousandths by 060 and glued it together. Well, where did I get the 13 thousandths? Well, when you open a pack of styrene up and measure it with the dial calipers, it may say 10 thousandths, but chances are it might be 9 thousandths, 9.5 thousandths. It could be 11 thousandths. It could be 12. You could also take HO scale styrene, which 1 inch is going to be just about 11 thousandths, but a lot of times you find it 11 or 12. So I take and measure, mix and match, and make custom widths if I need it using that method. So let's take a look at the end view of that cutting guide and exactly what I did. The black piece represents a piece of brass or styrene, and we have a nice square edge on that usually on the brass or the styrene. And the guide is going to have this blue piece that's a heavier strip. That would be the 60 thousandths by 10 thousandths piece. And that was the beam. And the desired width strip in light blue is glued to the blue piece, raised up a little bit to create a lip. So now you could move the brass or styrene up against that lip and pushing the two together, holding the ruler or straight edge guide up against the desired width guide, And then moving the styrene guide back, you could now scribe that. And here we're going to show that in the next photo. Any questions on this photo? Here's an example cutting 10 thousandths in thinner brass. On the left photo, you could see the guide pushed up. In this case, is I want to cut a strip 0.030 wide, and I'm pushing it up to the brass to the left. If you notice here, and you may ask, well, why did I, in the previous photo here, why do I make a left and a right piece? Why didn't I go all the way across?
Mm-hmm.
Look at the visual. You could see that you got it pushed up. See the gap? You could tell whether or not you're pushing it all the way up against the piece you want to cut. So over here on the photo on the right, after holding the ruler, I'm now scribing it with a, in this case, X-Acto. Use what you want. Here's another photo positioning this type on a piece of styrene, but it could be brass. Again, I'm holding the cutting guide up against the styrene, pushing my cutting ruler up against the guide. And again, you could see that gap. I know I have it flush. And here I remove the guide, scribed it, and cut it. Now, when you're cutting the brass and you have long strips, it's hard to grab this little piece here and snap it off. And that's where these things come in handy for both brass and styrene. When you have that longer strip of brass, this is like a little vise, little clamp, and you could clamp in your brass or styrene into the photo-etched bending tool, and it becomes a vise and holds it, and you could now snap that little piece off. So here's the UUM USA fold and bending, the photo-etched bending tools. These have size M6 star knobs, as these, I believe, come from Czechoslovakia. I believe they're made, and they're metric. I removed the Allen screws at the advice of a friend, Peter Howie, I believe he pronounces the last name, and he used star knobs, and I got these off of Amazon, and they work much better than an Allen screw where you got to use an Allen wrench. But you may ask, why so many? In the photo, the center rear was the first one I ever bought, and it works so well. I bought the one on the far right, a longer version, which is about 6 inches. Then they came out with an improved version with a folding or bending brake. So I bought the short center one. That works so well, I bought one of the long versions with the bending brake.
No.
So here's a picture of the UMM 150 millimeter close to 6 inch bending brake. That would be the first long one I bought, and that has the Allen wrench to tighten. So after we scribe a sheet, we could use this to hold and fold and bend. And here's the link to UMM, but that's also in the handout that I provided. So tightening down the sheet of brass with the scribe mark on the photo on the left, we inserted into the photo-etched bending tool. Where the red arrow is here, that's a heavy metal straight edge. I believe that was from a combination square, probably a 6 inch combination square, which makes a nice edge to help you fold and bend the brass. You can see me being sloppy, putting finger marks in there, dents. And on the photo on the right, you could see I bended back and forth. And on the third time and third bend, it broke off. And here I am measuring it with a digital caliper. And this caliper I had for well over 20+ years
Hmm.
until just recently when somebody that was clumsy, being me, knocked it on the floor and broke the glass.
Oh,
So, got me a new pair of Brown and Sharp. Um, but you can see here measuring, I've got exactly 30 thousandths. As with when you cut styrene, you sometimes get a little raised lip or you damage the edge, and you could clean that up with a sanding stick or a fine file over here, like on the right photo.
when you broke the strip off the brake, did you score it first? While it was
Oh,
in brake?
oh yeah, yeah, that was scored.
Yeah, okay,
I think I
okay.
had on there
Yeah,
to
Sure.
line it up. To line up
right.
place sheet with the scribe mark aligned with the edge.
Okay,
That was
okay,
back here.
okay.
Yeah, and there it is aligned, and I start bending it at that scribe mark.
Yeah.
And if it's real thick brass, you want to make a couple multiple scores. Styrene, you may score once and bend it and break it off.
Mhm.
For this, it's usually, you know, 2-3 passes. It's a trial and error. Depends upon how hard or soft the brass is.
Mhm.
So let's make some parts. Let's make a angle from 5,000 shim stock. So you see the picture on the left. I have scribed the brass, 5,000 brass, and I didn't use my layout die trick on here. I just scribed it. I made the one mark 80 thousandths and the other one at 35. The difference being, and I didn't go with 40, is sometimes when you make a bend and you bend in the center, you're not really bending in the center. So I offset it by 5 thousandths for my bend.
Hmm.
And on the right-hand side, you see the scribe line is lined up in my smaller, newer bender with the bending brake over here pictured on the right. And this is K&S small sheet brass, which I like working with. That's a shim brass.
Hmm.
And here you can see I lifted up the sheet, the bending brake on the left, and you could see I didn't quite bend it all the way because I want to be able to get into the area between the photo etch tool and the brass to push it back. And I don't want to just push it up here because I want to keep a sharp edge on that. So sometimes I'll take a ruler and put it in here between the brass and the photo etch tool and then push it back the other way.
Ah,
And then it snaps off, or you push it back and then raise the brake again and then, you know, put the ruler in there and bend it back the other way. And it helps keep you damaging the rest of the sheet. You could see some marks here. Actually, it's a reflection of the Allen here. So the photo on the right now shows I have an 80 thousandths wide piece with a not quite so centered bending mark. Here we're going to put it back into the bender at the scribe line, and we're going to lift it up, the bending brake up as pictured on the right. And here's the L. Probably not perfect, but close. So what do I do with the door track? Here it is being used, or with the L. I actually use that one for an IC Illinois Central brass door track, and you could see it here installed, somewhat installed on the car in position. And there's also, if you look closely, there's a piece of white here you see at the front of it. It's hard to make a U-shape bend. I haven't perfected that yet. So to kind of simulate a U-shape of the door track with a lip, I use 10,000 by 10,000 styrene glued to the front of that door track to kind of simulate the L shape. I'm sorry, the U shape.
Hmm.
So let's form some clamps for holding wire, small wire loops, making a brake step, stirrups, and lateral running board supports. Another trick I came up with is flattening brass wire, and I usually use Tichy photo etch. I'm sorry, a phosphorus bronze wire, but you could use a brass wire as well. I use a pair of pliers from Xuron. They're called short nose pliers. They're smooth nose, part number 475C, to flatten small diameter wire here. And you could see on the right, I took a sample of flattening 8 thousandths wire, 10 thousandths, and 15 thousandths. And I just went in at a right angle and kind of flattened it. You could see the results here. So what can I do with this? I could make little clamps out of this to hold wire. And I'm coming in on the picture of the left, I'm coming in long ways now, not at a right angle. I'm coming in long ways because I want a longer flat surface. And these have a lot of torque. You could really torque down and flatten, as you could see here on the right, the result of flattening it. So now I want to make a loop into this flat piece of wire. So I'm using, and you see a lot of green here. This is green frog masking tape that I attach a sticky side up to a, if you've ever heard of it, machinist blocks, like 1, 2, 3 blocks. And I have a few of those that have no holes in there. They're machinist setup blocks, and they come in handy, or I find they come in handy for me because they're heavy. And I tape my green frog tape sticky side up to it, and I have a hard working surface. And I took a drill bit, number 75 drill bit, probably an old dull one, sharp, not sharp, maybe broken, and put it on the tape, position the flat wire that I flattened over the center of the drill bit here, and then going in with the Xuron short nose pliers around the side here as pictured, straight down from the top and pushing hard on that surface. And this is what you come up with on the left.
Oh,
So what can I do with this?
Hmm.
Well, I could make a right angle bend, leaving part of the stem on here and drill a hole in the car, and I could secure a small piece of wire.
mm,
Now, as pictured there on the left. Now, an alternate method would be to cut a strip of brass, and this one was a little bit wider than I'd normally use. But sometimes what I do, because it's sometimes hard to drill and center a hole on these small pieces, is to sometimes use something a little wider. So this is probably a 3/1000. It is a 3/1000 flat brass strip that I cut probably it looks like to me it's probably 35, 40 thousandths. And it was formed over a brass drill as well, bent around it. And with the hole drilled, you could pin this to a car and you could trim this end if you want. So now you have another style clamp. You'll see this in another picture coming up. Making small loops in that. And I found that when you're attaching and working on the brakes on the car, where you have the chain coming from the brake cylinder, or on the B end of the car, you have the brake rod with a piece of chain attached to the gear, the brake gear housing. And you want to attach it to a small diameter chain, like a lot of times you use roughly 40 thousandths per link, inch per link chain. How do I make small loops and how do I make them consistent and that? So this is my method. I start by forming a wire, and this would be 10,000. This should be 0.12, should be 12.5 inch diameter wire. You start by forming a loop with chain nose or needle nose, round nose pliers. In this case on the right, I've taken a piece of basswood, and I've drilled a couple holes and I put some pins in here. On the right is a 12 thousandths diameter pin, and on the left is a 20 thousandths diameter. I take my loop and put it over the pin. Using this around needle nose pliers, I go in from the top down and I start closing that loop around that pin. You could see on the left and on the right, you could see it pretty well closed. You could see it won't close completely. It needs to be snipped off here and closed a little bit. And I would do that normally after I attach it to the chain here. You could see the picture on the left, and here's the chain. And on the right, you could see it attached to the chain. It still needs to be just tightened up here a little bit so it doesn't slip out. But you could get nice, consistent bends with a little bit of practice, and you could make them pretty tiny. So in constructing the freight cars and that, I like to use brass brake steps in that where possible, the guides that are supporting brackets, and to make those consistent, measuring from some photographs, I came up with a brake step bending guide that I made from 30,000 styrene, as you see this triangular area with colored with a black magic marker, and it's to the rough shape that I want to form it, with the bottom shape here being kind of rounded. And that's on a scrap styrene base using some 5 thousandths by 30 thousandths wire. I bend this to the approximate shape. You can see nothing is really all that tight here, but it's formed to about what I want. Once you remove it from there, you could, with your tools and fingers and pliers, you could clean it up and make nice sharper bends. As you could see here on the left, this one's pretty well finished. I did drill the holes in here so they could be pinned to the end of the car. The photo on the right shows 2 of them here that are one not being quite trimmed here yet. And on the upper right, you could see the actual brake step that I cut and I bent 2 lips on. I didn't cut the hole in here yet though for this one, but that'll be a brake step. You could see here on the left photo, I soldered the brackets to the underside. Not very clean. I'm getting a little better. We'll talk about that in a second too. And you could see that the here at the left side, you see some holes. These brackets were not finely bent until after the soldering was done. On the right-hand picture, you could see the brake step mounted into position, and you could see it pinned to the car. And also here, I wanted to point out these photo-etched ladders that you see on the car were some of the custom ones that I did with that modeling friend, Tony Sissons, that helped me do the CAD artwork, and we sent off to an etcher. These are photo-etched styles, are to scale. They're individual rungs, and each rung is pinned to the style with a brass pin cut off to represent the bolts, because you see the formed heads as they would be on the prototype, and these are almost to scale.
George,
yeah.
You may want to mention what you're using for pins.
These are brass pins.
Okay.
These were 10 thousandths brass pins. The holes were etched to be 10 thousandths on these. We'll move on here. Whoops, it's a little bit too far. Okay, making your own stirrups. A friend of mine bought a few Southern Pacific Athearn PS2 3-bay hoppers, and you could see a before photo here with the stock steps, the stirrups, and the brass piece, or the one triangular piece here. holding the stirrup, and they just didn't look good. They're clunky.
Mhm.
And I found a drawing in the Car Builder Cyclopedia of the actual PS2 hoppers. And besides from being not quite the right size, they had a center step. These were typically used for 2-bay hoppers. The 3-bays didn't appear to have them, and the Southern Pacific did not. So I formed some new stirrups, but I wanted to make them consistent. And also, you could see the cut lever is here with there's a little eye loop, Yarmouth eye loop put in there to hold a cut lever. So you can see they look a lot more delicate, and they are pinned from the bottom, and it is soldered here on the right-hand side to this plate and then pinned to the end of the car. So here's how I did it. I made another fixture or template from the measurings of the car builder's drawing. And there's a rectangular one here in the center. That's for the left-hand stirrup. I don't really have pictured. And this is the right-hand stirrup. And you could see how I formed and started to form these around this fixture.
Mm.
And there's the piece here, on the left that is drilled, and then the bends, and then you could see here on the left, the finished ones. I know I got this kind of backwards, where it's bent and cut. And this line here was after you bend up this edge, you cut it here. And then here on the right-hand photo is the piece I cut from 5 thousandths brass. You can see a scribe mark. You can see a hole here for the cut lever, the eye loop. You can see it's soldered at the line here to the one side, and you can see a couple holes here for pinning to the end of the car. And here's another view of how I laid out and cut these end pieces, and that again using my tape as a holder and a couple of scrap pieces of styrene on the tape to form a right angle. The 5,000 strip brass is pushed up in here. It's coated with magic marker as a layout die, and here's my scriber. And then this holds nicely in place while I use calipers and such to mark positioning and put cutting marks and drill marks on here. And you can see a couple here on the right-hand side here. And I did cheat here. Rather than drilling 2 holes, I started putting one that was sufficient to hold it. That's how I did these, and I used the Xuron shears to cut these out. Cutting short pieces with the Xuron shears, you don't have much to worry about bending or curling. It's the long pieces that you have problems with. So photo etched ladders, they do look good. When I first did these and that, and Lester could attest, him and I talked about it. It's like, well, how do we even build these things? A modeling friend, Nelson Moyer, came up with an idea similar to what I did here. But I took, and this is my method and how I construct my assembly guides. Important thing when you're assembling ladders is you keep everything square. And you keep the rungs that you put in bent square. You keep the stiles square, and both in the X and Y direction. And here's how I do it. Let's take a look at an end view of my photo etched ladder assembly fixture and considerations before we're going to build it. The red piece in the center is the make-believe rung, and it is a certain width, and that it could be 16-inch, 18-inch in scale. So the 16-inch would be 0.207, I believe, and the style, the photo etched style, is bent in the center and is held at a right angle. It is raised up here. It will sit down in the fixture. this is just to show you visually what we're dealing with. The style is a certain width when it's bent. So looking here at the left-hand part of the arrow, to the right hand is a certain dimension. And that's usually roughly somewhere 20 some thousandths. And we need to take into consideration the style width cannot be the same as the rung width. We have to add that half the distance on each side. So we come up with the proper spacing in that. And the white represents styrene here. There's a base. There's a, for the left-hand style, a support on the left here and the right-hand style again on the left and the right. And that's going to be roughly just a little bit bigger than the width of the style here. And this wasn't a handout. I did copy this whole section out if anybody's interested. So for the correct spacing, I first cut one or two of the styles from the fret. And when you cut styles from the fret, and that you sometimes have a little burr here you see that's on the right-hand photo. This could be cleaned up with a file. Lately, you see some marketing with photo-etched files and that. Typically, those are nothing more than diamond files and that you don't have to buy one made specifically for photo-etched. You could use a fine diamond file that is usually cheaper. I forgot to put one in a picture. I do use those. So what I do is I measure the total width of the style, which is, in this case, just about 50 thousandths. But we need to fold it. And when you fold it in half, it's going to be about half that, or about 0.0252 in width. So this is where we have to take the rung diameter, the rung width, which is 0.207. That's for 16-inch rung. And we have to add roughly half or 12 thousandths twice to come up with and get the positioning for the styles. So taking my dial calipers, the digital calipers, measuring and marking on a piece of styrene, which is, I usually use 30 thousandths for a base. And it was marked with a square. I've got two parallel lines. Using my square, I glue a 30 thousandths by 125 to the left side of that scribe line. And then on the opposite, on the right-hand picture, measuring with my dial calipers after that dried a bit, and making sure I maintain my 0.230 distance, which was wrong, wasn't it? Or did I goof? Yeah, 0.230. I'm getting lost here. Keeping it parallel and using the thin beam square, I glue one to the right-hand side. Now we've got two parallel ones, and we need to make the inside support for the style. And I choose again, a 30 thousandths by 125 strip. The center ones don't matter that much for size. And I'll explain in a second why I did it this way. Here is a cut piece of the fret that's the width of the photo-etched style, and I stand it up as on the right-hand picture and glue the other 30 thousandths by 125 in place, leaving this so I could move it. I don't want it tight to where I can't move it. I want to be able to get pieces in and out, but I want it to stand at a right angle. In the next photo, I can't fit a 125 wide piece in there. So I choose a 80 thousandths wide piece to make the other side of the guide and glue that in place. And you can see here in the left picture, the the style from the fret standing up and the guide glued in place. The first ones I made of these, because occasionally you need to make custom sizes, and that if I've gotten styles where the holes are not centered, so when you make the right angle bend, it may not be centered, and even though it's off only by a couple thousandths, when you're dealing with close tolerances and that, you could start warping and bending your styles and that where they're not straight because your rungs were bent to a certain size, but the holes are off. So now you're bending and warping your ladder. So I'll make custom sized ones. I used to try to cut that center to the exact width that I needed. And then I thought, well, that's foolish because I don't care if there's a gap in the center. What I care is that this is parallel and it stands up straight. So the photo on the right, I'm bending a style where I line up the style that was cut from the fret on the line. And the next photo I show, I bent it up with the bending brake. Kind of hard to see it's bent. This has the star knobs in there for tightening. And here's the finished one bent on the photo on the right. And here's a better photo of the styles bent to a right angle. And you want these at a right angle because what happens is when you put this in the fixture on the pictured on the right, if they're not at a right angle and that style is sitting up in the air or forcing the style up, when you glue everything together, it's not going to make for the best looking ladder. So we're going to start here. You can see how these are sitting pretty square. We're going to take with the two styles inserted into the fixture. I just use a scrap piece of styrene cut and taped with a little pressure to keep these from jumping out of the groove. So in case you knock it, and it gives a little friction. So when you move this back and forth, you can see one rung here placed in here at the bottom. We'll show you another photo here in a second. The photo on the right shows my method of applying CA, and I use a thin CA. What you see here is a little pill cup that I buy on Amazon by the hundreds, and I cut them down to a more appropriate height and that. And the reason I do that is so I could go in with my glue applicator, which in this case, the glue applicator I use for CA is from a company called Glue Looper. You could use a pin, you could use whatever you want. I like this because it has a curved applicator with a hole in it. And that holds a little CA, and you could dip it into this CA, which is held up on an angle with a little piece of wood block with green frog tape reverse wrapped around there. And it holds it on an angle so it puddles, so you don't have to have it flat. It's easy to get. That's my method of using and applying my CA. So once I have a rung in place, I glue one in place with the CA, and usually it sets up pretty quick, but you let it set up maybe for a minute or so, so you make sure it's hardened. And then you push the ladder styles forward and keep applying the rungs in place. And I make sure on my guides, if you look at here where my arrow is, the top of the fixture below this rung, I make sure all this is square, from edge to edge. So when you put a rung in and the holes, you could visually picture and place these rungs close to or the holes close to the edge, and this is square. And that your eye is a good, very good measuring tool and judge of whether or not how it's going to look when you're finished. One word of caution is when you do glue using CA, you do not want to be right up against the styrene because capillary action will usually glue your style right into the fixture. So on the right-hand side is a photo of the finished ladder, well, almost finished ladder, with the rungs glued in place, because when I first started making these ladders, this is how I would do it. I would say, I am done. And I'm going to show you something in a second. There is a rung left out of here because for some applications on freight cars or cars, I leave a rung out and I will place this on the side of the car, and I'll also drill holes and put in longer rungs into the side of the car, and this way they do not fall off.
Hmm.
When I say I wasn't done, this is why I said I wasn't done. I turn it over now and I glue from the back side. I apply additional bit of CA because this will help reinforce and give you good rung strength and also strengthen up. So if it's bumped in that, it stays square. So I apply a little bit extra to the back to each rung. And then from when that's dry, I go in from the back side and I trim each of the rungs with a pair of diagonal pliers. I use rungs I make myself from brass wire. I usually use 10,000ths, but occasionally I'll use 8,000ths, which is a little bit more to scale, but they are a little bit more delicate. This is how I make them. Once you do it this way and you start, you could make hundreds of these very quickly and very easily in that. I know some people use fixtures. Why I don't like the fixture is I still usually have to go back and clean up and try and make sure I got a good right angle. So if I'm holding it and I measure each one while I have it, I could take care of that right away without going back to it. So here's some 10,000ths Tichy phosphorus bronze wire. What I do is I set my caliper to the desired width of the rung minus one leg, or roughly, if you want to say half, because a 16-inch rung, if you bend 10,000ths wire to 16-inch, is going to turn out to be bigger than 16-inch. So you have to calculate and subtract the half the diameter, or one diameter, if you want to say, from the measurement. So 207 minus 10,000ths gives me the 0.197 that you see up there. So here I start out, and thanks to Bill Welch for this tip with using these Xuron 575 pliers that were actually used for jewelry that make a good 90-degree bend. So for that first bend, you make the 90-degree, you start it, and you could, if you want to use this tool, you can, to make a really super 90-degree bend. And I put one end of it into my calipers, which I have laying down, and I often tape to a flat surface so it doesn't move on me. You can see I have Xuron smooth nose pliers holding and pushing against the right jaw, and the Xuron plier is tight against the left jaw. I could now lift that up and bend that. And you could see here, here's my finished rung, and it's nice and square.
Oh.
And the reason I stress being square is the squarer you have this to a square style, the better your ladder will look. Now, if you want to make drop rungs, I came up with this method. It's a little tedious at first, but I wanted to make some consistent drop rungs in that. And using the Photo-etched bending tool, I have a line on the bending brake, and I insert the bent straight rung into it leaving roughly a 30 thousandths gap, which is this line. And you can see one here roughly in place, and on this other one sticking up will be positioned into the bender. And if you want to put a piece of styrene straight down, you could help position this. And you tighten the knob up a little bit so you have a little friction, so you can move these by friction in and out. And when you lift up the bending brake, you could see here on the right, we've got some nice right angle drop grabs. So for mounting the brass photo etched ladders and that, I'm pictured on the right, I usually make some little standoffs out of styrene that I CA to the inside of the stiles. For cutting these and that, what I do is in using either in roughly 15 thousandths by 30 thousandths stood up on edge. So these are standing off the side of your boxcar a little bit. I cut not consistent. I mean, you barely see these, so they don't have to be exact, but I want them close. So I found by taking this one piece here, the horizontal piece is the 15 by 30 on that green tape. And I have a piece of roughly 40 thousandths wide styrene stock here, the longer vertical one. And I made one cut with into the 15 by 30 going straight down, and then taking my spacer here as a guide, and you place it on that styrene, move your razor blade, cut to this side with the razor blade in place, you move your styrene and you alternate, and you come up with hundreds of these little pieces that are stuck to the tape that you could grab with tweezers that don't fly all over to glue in place. So here's a picture of some stiles mounted to a boxcar. This style was what they call wine ladders, and the rungs are not bolted to the front of the stile, but they actually have a S curve and go into the side, up and across. And to simulate that, you can see where the arrows are. It's kind of hard to see it. Some styrene pins I drilled holes into the side next to each of the rungs before I assembled these, of course, and simulate the ends here, which you could see on this ladder here on the resin side. And here's the finished results, and you could see a brake step mounted in place with the ladder mounted in place with the additional bracket here that's mounted at the top, which was used on some of the older cars did that. This is a one slide I just added that I am working on the 2023 Chicagoland RPM mini kit gift that was given out at the RPM meet, and it uses a style ladder. I use the Yarmouth brass, and I'm assembling it here, but it uses those brackets. So I thought I'm going to try and make a bracket for the prototype, that the bracket, which will have some bolts here to the side of the car on the left photo, but they formed a U shape around the top and bottom of the stile. And you could see here my result of my first one I made here. I wanted to show and try, and I like to try and push the limits if I can. And I don't know if this is pushing the limits, but without trying it, I don't know. But this is kind of what I like to do, is to do these kind of things and simulate the prototype as best as I can. So this is my first attempt at doing and forming it like this. Lateral running boards and brackets. For that one Rock Island car you saw at the beginning, I made from my cut strips of brass and I soldered. The early running boards use sometimes a different style of mounting, and you can see there's like two layers on when I'm looking at the arrow here. there's two different layers of brass, a wider piece and then a narrow piece. And I cut to size and soldered and bent at the edge here of the roof. I made one for the right and left. I drilled holes and soldered in the grab iron. And when that was all in that, I'm sorry, here at the rear, I took a piece of styrene that helps support the back of it, which will fit right underneath the running board. And I glued, in this case, you could see it on the right, there's a finished car. I glued and scribed wood grain into styrene to represent the wood running board. Since then, I came up with another method where you doesn't use that style of making supports for the lateral running boards. And I like to drill and pin these. And I thought, well, Yarmouth makes some nice stirrups in that, and you could buy them with one hole. And it's like, well, why not utilize those to make lateral running board support? So I started and I took some straight stirrups and I cut them in half. You can see here on the left, and I bent them to be the appropriate distance from the edge here to the underside of the lateral running board. I CA'd these in place. Once they were dry, then I would drill a hole for 125 thousandths wire to be pinned. And when that's all dry and you go to install your running board, you install your glue here and at the back, and you're done. And here's the result of it. Here's on the left, pinned, glued in place, and the right shows a picture of it painted up. It was a Great Northern double-sided boxcar. I should mention too that if you want a longer one, you don't have to cut them in half. It's just you get a higher yield because you don't really see what's underneath there anyway. But you could let it run the length of the lateral. Sometimes in my note here, not all parts are, some parts are, I should say, some parts are weak because they're sometimes etched too far through, and it creates at the bend points, as you see here on the left, you see a groove here, and sometimes it's very weak and you bend it and you touch it again and it's going to break. I like to reinforce it, and there's two ways of doing this. One is with solder, and the other is, if it's not too weak, I'll use CA to just reinforce that just by putting a little bit of CA into the groove, the bending groove after it's bent, and that'll reinforce it. Pictured on the right here too is my bending tool for the wire loops. If you look at the air hose bracket, this is a Yarmouth part to support the rubber air hose that you put in here. I use a 20 thousandths pin, and this is 8 thousandths wire, and I bend these using the method I showed you earlier. The 20 thousandths with 8 thousandths will give you a perfect fit into these holes here. You see these two holes at the top that will secure your rubber air hose. For soldering in that, I use an electronic soldering iron for the most part. I do have some old hand ones and low wattage ones, but I like my electronic one. And the reason I choose this Haskell one is this Haskell one, besides being digital, and was priced right, I don't know, about $80, has a very flexible, workable cord that doesn't impede my hand motion and holding, and it has a very well balanced handle in that, and many different tips. I tried a couple, and the cord, when you're doing soldering of small things, if it's too stiff, is your worst enemy because you're fighting against trying to get it to where you want it to go. Weller makes some nice units too. This is the one I bought at the time. And I bought this not to solder brass, but to solder LED when LEDs became popular about 5-6 years ago, and installing decoders. I purchased this to do the soldering of decoders and LEDs, making my own. Pictured on the right is what I use for soldering, and that I use some green type flux paste, which is non-corrosive and environmentally friendly. I used small diameter solder. You see a X-Acto knife here. I don't cut anything with it. I use it to dip into the soldering paste in small quantities to apply to the joints that I want to strengthen. I've used to use toothpicks. Toothpicks seem to pick up way much more than I want, harder to control. So an old dull X-Acto blade seems to do the trick for me. I'll show you here in a second. We're going to go ahead and put some solder on those Yarmouth air hose brackets. Here being held again by some green tape. You could use 3M blue tape if you want. I just bought a large quantity painting of the house of green frog tape. The X-Acto number 11 blade was used to apply a small amount into the bent air hose bracket. You can see it's kind of a Z shape here. And with that small amount of flux, using the soldering iron tip, which normally my process is to clean the tip, bring a small, extremely small amount of solder up to the very, very, very tip, barely touch it to where you almost have nothing on it, and just touch it to the place where you put the flux. And a very, very tiny amount goes in that. And you could see here the joints on the result pictured on the right, where there's a little bit of solder in the one bend here by the longer edge, and where the two holes are going across, you could see a small amount. And of course, you don't want a lot in there because you do not want to fill these holes up and drill them out if possible. Which, by the way, early, excuse me, let me just get a little water. Earlier in that, I showed the Goering drill bits being a number 9. I use that number 9,000s to clear these holes out for the air hose brackets when you insert the 8,000s wire into it, so they go in easier. That was bent around that 20,000s pin. As noted, the photo etch parts can be fragile and easily bent when handling. Even with the stirrups in that, they could have a weak corner where you bend them. And on the left, you see the 12-inch straight stirrups from Yarmouth. These you drill a hole and push into these sills of the car. You can see the bend marks here for these when you bend them, and if they're etched too far through, they may be a little weak. They're real easy to just go ahead and put a little solder in there, bend them at a right angle with your fingers or tool, and go ahead with the flux and just touch that tip to it, and it creates a really nice strong stirrup. And that you know how the stirrups have a tendency to get knocked when you're when they get handled in that. So or if you don't want to use solder, just use a little bit of CA. But if it is a real weak and etched too far, solder works great. Attaching parts with by pinning and gluing with CA or canopy type glue. From the military side, which I often visit some of the military sites and look for tips and tricks and things that are new over on their side, because they seem to get things first. Back a couple months ago, I ran across this glue from MIG Ammo, which is a Spanish firm who makes a lot of good quality paints, glues, and other things for the military side. And they also, MIG Ammo also makes a nice, I'll give them a plug, a line of um, railroad colors now called the Rail Center acrylic paints that are just wonderful, and that I've gotten some good results. Anyway, they came up with this glue they call Ultra Glue, which is a PVA type glue, kind of like the Canopy Glue 560 on the right-hand photo that you see. Canopy glue, my Ultra Glue, and some CA Flexi glue that is supposed to be for photo etched. I have had I haven't had good luck with that glue, any of the CA glues or Flexis. And I tried this, and on the back to the left picture, you could see a piece of white styrene with a couple little pieces of brass glued to it. I'm sure I could get these off, but I cannot get my fingernail under there. I cannot move these at all, period. So I thought, well, I'm going to try this, and let's try this on a resin car build and a photo etched Plano running board and that. So here's my method of gluing it to this particular car. I have a microfiber brush here, the purple one. I have a coarser file, and I'll show you here in a second what I'm going to do with that file. Is the backside of the running board is coarsened up with a coarse file. Make sure you do the back. And I apply my Ultra Glue to the running board supports or saddles using the microfiber brush. This is a water-based glue. If it gets too thick, it could be thin with distilled water. And I did that because I know that it can, because I left it open one night being stupid and thinned it with water, and it came back just fine. So next photo, kind of hard to see here with the grays, but these are the saddles, and you can see the Ultra Glue applied to each of the saddles. And my method is usually go across each of them once and then go back, go in one direction and then go back and make sure it's applied, and if need be, touch out each of the saddles. Put down the running board from the top down, centering it, and it doesn't set up instantly, so you could move it and position it right and left and right to get that centered. In this particular car, I have a piece of basswood that's nice and straight, and I usually support the car so it doesn't rock. But for the photo, I didn't. So they usually use those 1, 2, 3 blocks that are nice and square and up against each of the side of the car, the front and the rear, the wood on top of the running board, and put weights on top. The full cure time of this is 24 hours. I've tested it in about 6, and it's pretty strong. But because I want to make sure it really sets up, I usually let it go the full 24 hours before I start doing a lot of handling with it. I could tell you it sticks. It sticks like glue is all I could say. It really does work, and I've tried it on a few other things, and I've been very pleased with it. It's about $6 a bottle, depending upon where you buy it. It shouldn't cost you more than 6, but there's a lot of markup on it because it comes from Spain, and it seems like you pay for postage from Spain and that. So, so anywhere from $6 to $10. Karmer cut levers and that, or some of the box cars use this older style. It's a 2-piece assembly that is a photo etched part from Yarmouth. They're kind of flimsy in that when you're working with 2 pieces. So what I do is to solder them together, and you can see one here installed on the end of a box car. Is on a piece of wood stuck over a piece of stainless steel wire in that, and I do have and I use stainless steel wire because solder does not stick very well with stainless steel unless you use proper prep and solders and such. So I place this over a pin, the cleaned up photo etched part from Yarmouth, and put a little flux on there and hit it with the soldering iron, which is a tiny bit of solder, to solder the two together. Here you see the two pieces, and here at the top is one soldered together. Now it's easier to handle, and if you do bump it and that in operation, they stay together better. And here's the mounting of the cut lever on a car. I blew this up and that, and in this case, what I did is I took a 15 thousandths brass wire, and I used some micro tube as a spacer that goes into a block on the underside of the car here by the ladder here. And the tube keeps it spaced out the proper distance for the uncoupling. Here you can see the tube underneath here. It's just an easy way of mounting, and it's not that visible, but allows for a nice mounting of the cut lever here. And here's some examples of using brass and photo etch parts. Well, not quite brass, but this is close. This is came from a modeling friend, Tony Sissons,
Mhm.
and in gluing and assembling LED and soldering my own LEDs, I had this magnet wire, which is used to wind armatures and that, or motors and such, and also used for the assembly and wiring of LEDs. Like 0402 would be 20 thousandths by 40 thousandths LEDs. And I would buy those unwired when I first started. You couldn't hardly get the wired ones. So I did my own, and I bought a couple of sizes, 34 thousandths, I'm sorry, number 34, which is 69 thousandths, and number 36, which is 50 thousandths. The 50 thousandths or the 69 could be used and twisted together into a eye loop if you want. And I form this, usually take a old drill bit and like a number, if you want a smaller one, you could take a number 80 drill. So that's 13 thousandths. And you could start twisting wire around that and twisting the drill bit or the wire holding it, twisting it, and you can see it's twisted here. The loop is formed, and you could see the wire is twisted. You could, in this case, because it was magnet wire, if you're going to solder, you want to clean this enamel coating off. So you can either burn it off with a soldering iron, pushing it through solder, or if you have a Bic lighter, I found works just as well, to pass this through the flame of a Bic lighter to burn the enamel off. And you could solder it. And why would I do this? Well, in my case, in that I like to make these little eyelets for the brake for the release on the triple valve. And you can see it inserted here in the picture on the left, drilled into the triple valve and mounted. And you could see it's a nice round piece. And you could use these for lift rings if you want as well. Just use your imagination in that. But this is cheap, easy to make, especially if you run out of eyelets or to run out of small ones. And you can see it painted here. This was not weathered, so it's kind of hard to see, but you can see one mounted in place with the release rod and going through it. Here's a sample of a L-shape door track installed on a GM&O Speedwich, like a mini kit, which included a branch line car, doors and such. And I scratch built a new underframe for it, side sills, and I wanted a brass door track And well, how do you attach it in that? And I thought, well, I'm going to make a longer leg. So I'm not going to make an equal L. It's going to be a longer leg, and the leg is going to, long leg is going to be wedged and laminated between the underside of the car body and the side sill. And if you look at the picture on the left here by the arrow, you could see a 5 thousandths thick spacer where this is wedged in and glued in place.
Hmm.
And it will never fall out. Making some L's and making special shapes. Southern Pacific, I got a drawing, general arrangement drawing of the underframe and mounting the triple valve in the reservoir. And if you look at the picture here on the right of the mounting of the triple valve, you could see the unusual shape. There's two L-shaped brackets that come out, and then they're flared out. So if you look at it, it goes around the train line coming out of the dirt collector and down into the main train line, and that it's flared out. And on the right, you could see the forming of the L's were bent in previous methods we showed, and I had to make small cut marks in here so I could make the angled bends and bend them. And when these were all formed, then I would solder these with a little bit of solder in place to keep their shape, because they are quite delicate. And you can see this other one here for the reservoir, this one long one mounted for the prototype and the drawing. And then on the left-hand side, you could just see a simple L-shaped one. Here's from a Chicagoland RPM mini kit and that, and you could see my reservoir, which is a Tishy part mounted to the sill. And you can see the brass piece that's bent is mounted, and it looks like it's being held by the reservoir, although not 100% correct. Some people would glue the brass to the top of this piece here, because this would be the Tishy casting, using a micro saw, which has a blade of about 5 thousandths thick. I saw 15, 20 thousandths underneath the casting for the Tishy. You can see here, it's not probably quite even, but I saw into and parallel to the reservoir, so I could slide my 5 thousandths brass mounting piece into and supporting the reservoir, and gluing an Athearn rivet on top of each harvested rivet. This was a bit of a challenge to me anyway. This was not my first attempt because it had multiple angles. You could see where the crossbearer is on an angle. So this is smaller height here than here. Took me a while, a few tries to get it right. The dead lever here for the fulcrum, and that I bent from brass and drilled a hole and pinned it. On this particular car, for the brake lever, the support hangers, it's hard to see on here, but these were, I think, 125 thousandths brass. I flattened the ends, creating a round end, drilling a hole and pinning them to the center sill. And the photo on the right is just another picture of a BN with a clamp in place for the relief valve and the brake step pinned. And here's just a few more of those parts. And this one probably took me a couple, 3 hours to bend it. Here's the brake hangers you could see flattened and drilled. Getting them centered is a challenge. Here's a sample of finished red caboose Western Pacific PFE reefer with Yarmouth ladders. A tip when you're getting the Yarmouth ladders, and if you're trying to match a prototype, and it has bent or curved ends, which a lot of them did, I believe, for safety. They weren't just straight. If your car calls for a 7-rung ladder and Yarmouth sells an 8-rung ladder, buy the 8-rung because you could cut the extra rung off and use it to bend and make curved bends at the top or the bottom. If you look at the bottom rung here of on the B end, right by the cut lever, you could see how this style was cut, and it actually bends in and mounts to the flat side of the end. Does not stay a L shape.
Hmm.
It's kind of hard to see it there.
Yeah.
And then you can see some Plano latching brackets. The Plano ones were a little bit oversized, and I would file down and a little bit more to shape. Now Yarmouth makes a little bit, some that are a little bit more to scale, and it's hard to see the brass here, the hand grabs, but all this was all custom bent and brackets and that. Ted Collada did this on one of his blogs, and that and shows not my car but his version of it, and he did some custom etch for these particular cars that were rebuilt in the 40s. And these are Yarmouth steps on the bottom here. And this is kind of where we started in that. I just wanted to show one more slide I threw in here at the end of why I do this. This was that shake and take. Here's the stock Athearn roundhouse 40-foot double door, molded on grabs, molded on everything, boxcar, auto car. And here is my version, the Rock Island shake and take from Cocoa Beach with the all the parts in that I made, and had a scratch under frame and photo etch parts and so on. You can see there's a little bit of improvement. This was a favorite project of mine. This was, if you guys remember, the old Ribside Milwaukee Road roundhouse type, Athearn type car, shake the box cars that were fairly simple. AccuRail picked up the die, tool and die, and is now offering these. I took all the and shaved all the parts off, ladders and rungs, and use brass on it, photo etched. This has my custom made photo etched ladders on it that Tony Sissons helped me with, the custom brass brake step, holders, the sill steps or stirrups, a scratch underbody with brass parts in that to hold various things. And in conclusion, all I could say is practice, practice, practice. Don't be afraid to make mistakes. Try different things. And that's it. That's if you have any questions, I'd be happy to answer.
Yeah, two quick questions. Where did you get that really nice scribe? And the other question is, what's your usual method for fastening down the green frog tape sticky side up?
Oh, I just cut it, the green frog tape, I cut it to approximate length and cut 2 short pieces to put one on one length on each side of the tape, and tape that to the surface, whether it's you know, that 1, 2, 3 block, you know, and because I like to stretch it because I like that tape tight. I don't want it loose, so that I tape it that way. And the scriber is I got off of Amazon. It's a company called Haswaga, I believe. And what I'll do is that I don't have it here handy. It may be in my handout. If not, I could give it to Greg, and Greg could post it, I guess, on the NMRA group. Can you do that, Greg?
Absolutely.
Yeah,
Oh.
I'll take a better picture of it in the package. And what I liked about that particular brand is it actually came with a sharpening stone. You could sharpen the tip, and it
Oh,
has that rubber around it that you know makes it nice to hold.
Yeah, it looked really nice.
They also make some chisels, and I think the one I bought was 3 millimeters, I think, in width, and it came with also with a sharpening stone. And I like that one as well. So I'll take a picture of both, and it should have part numbers on them. And
Nice.
they did come from Amazon. They're priced in the probably shipped in the $12 to $15 range, I think.
Yeah, well, thank you.
Sure.
Mhm.
Great job, George. Thank you very much. We did have a request to for the complete presentation. I don't know if you want to share that or not, but the other documents are in the chat. The links to the other
Yep.
documents are in the chat if you want to get to those. They're also on our group IO for the Michiana division. And
Okay.
so you're welcome to that stuff.
All right. I'll think about releasing the whole thing. I mean, I was probably going to upgrade or keep upgrading and changing and improving and
Yep.
giving it other events as well. So,
Right.
uh,
Yeah, that was really great. Very in
okay.
depth. And I hope you take a look at the chat window before you log off, because there's a lot of thanks and kudos to you. So
Okay.
uh,
Good.
great attendance, great showing by everybody, and a terrific presentation. So really
Good.
appreciate it.
All right. Great. Thanks. Thanks for being patient. I know this was a little longer one.
Oh no, it was great. Definitely worth it.
Okay.
Mhm.
Good.
So thanks very much, and a reminder, everybody, to check out our conference that's coming up in on May 2nd through 4th in South Bend. You can find information on the Midwest Region website or by going to around in 2024 aroundthebend.com. Thanks everybody for coming, and have a great Saturday.
Thanks.
Thank
Bye.
you.
Yeah, thank you.